Hello and welcome to Getting Started with SQL Part 3. In this video, we are going to be focusing on primary keys and foreign keys and basic joins. Compared to the list of the previous videos, this is half the length. This is more than enough to cover in one video and not enough time. I'm trying to keep these sort of around 20 minutes. Don't know where this one will end up, but we are going to just skim the surface of what's available here. So if you have been following along, we've been working with a web store example. We've created our products table, but to truly harness the power of relational databases, we need multiple tables to be able to collect data from different areas. And actually, if we assume for a second our web store is akin to sort of a live database, it's all very well knowing what products you're going to sell, but we also need to keep track of our customers and we need to keep track of our orders as well. So I've popped together a rather crude little diagram here in Excalibur, and this is just demonstrating what the vision for this is. And I've had to take some shortcuts, but we've got our products table and we're going to create a customers table, but we are also going to want to keep track of orders. And it makes sense to do all of these together in one video. And this is where foreign keys are going to come in. In terms of our DDL and DML, we're not going to be covering anything new here, I don't believe. However, we are going to be covering some new sort of topics within those. So I would at least follow along if you want to continue on with the rest of the series. So let's go ahead and I'm going to create a new script, as I have done with the last videos. And one thing I haven't mentioned yet is how to do comments in SQL. It's the dash or the hyphen button. Let's just document. We're going to create a customers table, and it is important we do that one first. And then we're going to create an orders table. So how do we go ahead and do that? Well, let's come into our create table documentation. If you haven't got it saved, you can probably copy and paste most of this, but we can go ahead and create table customers. And we are going to have a primary key as we had before, so we're always able to reference an ID for customers. And that is going to be an integer primary key. And we're also going to set that one to auto increment. Next up, going to keep this table as simple as possible, but let's also hold an email address for people. And we'll set this to not null, because we never want it to be null. And there is a constraint we haven't used yet, which is unique. And we can put conflict clauses in there, as you can see, unique conflict clause. I'm not going to do that. We'll just say they must be unique as well. So this will ensure we always have an email address for every customer, and every email must be unique, so the customers can't sign up multiple times. Let's go ahead and create that table. Refresh our table view on the left-hand side if you're working within dbeaver. And then we now need to move on to the orders table and foreign keys. Let's just get the basic structure out the way. Table, orders. And we know this orders table is going to need another ID, integer, primary key, auto increment. And it might seem in these instances pretty pointless, why don't these tables have this automatically? There are examples we'll come on to later on perhaps where you don't actually need an ID integer primary key auto increment. You can have other values for primary keys. In this instance, we do need basically the same one. It's also important to note that the primary key we're creating on orders is separate to the one we're creating on customers. This is the customer's ID. This is the order's ID. If we're going to go in and create a customer we've already got products going up to number 5. But the first customer's ID is going to be 1. If we created one customer, the first order's ID would be 1 as well. The next thing, if we come back to our diagram, is we want to know what product has been sold. And to keep things simple, we are going to assume that an order only holds one product. And the sole reason behind that is, if you wanted to have orders with multiple products, you would then need some sort of an order lines table or something. I want to keep things as simple as possible. So we're just going to say an order is one product for one customer. If a customer wants to buy multiple things, they will have to place multiple orders. We can build on that later on again. So we want to know what product has been sold. If we go and have a quick look at our products table, the best identifier we have for a product is our primary key on ID. And we're going to use something called a foreign key to make sure that our products are products that we have. And I will explain what I mean by that. But we are going to keep track of the product ID. We know that product ID is an integer. And let's follow through this. We've done our column name, type name. Let's follow through with our column constraints to see how we would define a foreign key. So we come down to foreign key clause, and in here we have a flowchart for this. So the first keyword we're going to need is references, and we are going to reference the products table, this one here where the definition is here. We're going to reference the foreign table of products, and we're going to want the column name of ID. So let's say products, and then in brackets, ID. Keep following this round. We can then define what would happen if you deleted or updated. And if I come over to the SQLite foreign key support documentation, there's a couple of things we need to note in here. So the first thing is we're going to need to enable foreign key support, which we'll do in a moment. But the second thing is the description. And hopefully if you just try and build a few tables with foreign keys in, you start working with them, they'll start to make more sense. But the description of it, and I will try to break this down a little bit more, is usually the parent key of a foreign key constraint. So this is a foreign key constraint. The parent key of a foreign key constraint is the primary key of the parent table. So in our instance, we've got our products, and this is going to be the parent key of the foreign key constraint. So this is going to define this. If they are not the primary key, then the parent key columns must be collectively subject to a unique constraint or have a unique index. That's not to say that a foreign key has to be a primary key. It can just be a column or columns. As you can see in the examples down here, you can have foreign key JK, references parent CD, but these CD have a unique index put on them. So as long as they're unique, you can reference them. However, with this wording in mind, the parent key of a foreign key constraint is the primary key of the parent table. When we look at our create table syntax, we are saying on delete, so when the parent key deletes, what should we do? And in our context, this is going to be if we had 5 orders for iPhone, so the product ID will be ID1 in here. If we've had 5 orders and then someone goes ahead and deletes iPhone, what should we do? And there's a number of options for us. So we can either set null, and this would just null the product ID. So where we had 11111 for those 5 iPhones we sold, they would all be set to null. We could set to default if we had a default value against this row. We could cascade that change. So if the iPhone was deleted, any orders which had sold an iPhone would be deleted as well. Sounds like a bit of a nightmare. And we could also restrict that, which would restrict the delete from taking place. And actually, that sounds like a really good idea, because we don't want to go ahead and delete orders, and we need to know what products were sold, so we don't really want people deleting products if we've sold them. So I'm going to say on delete, restrict. The second thing we want to know is who bought something. And we're going to follow something very similar here. We're going to want to know the customer ID. We know that's going to be an integer. And we know we are going to, the parent key that we're going to reference is going to be customer's ID. In this instance, I'm going to go against all best practice, and so that we can have a look at what on delete cascade looks like later on, we're going to say on delete cascade. Please don't do that in production, for an orders table at least. The last thing is this table will look a little bit boring if we haven't got, if we've just got these two numeric values. So I think the other thing would be good to know is when the order was placed. And remember, we don't need to know what product or who ordered it, because we're referencing it through these IDs. So we are just going to add a column of created at, and then we're going to jump over to here. Again, this is a lot to cover in one video, but they've got a little piece in the SQLite documentation on date and time data types. To make things visually understandable, I'm just going to use the text data type, and we are going to set that as a default value of the date time function. And if you've used other languages like Python, and any language really, you'll be hopefully familiar with what functions look like, but we are going to say date time, and I believe in the examples below, make sure I'm closing that bracket. In the examples below, it does specify how we use these. Or up here, actually, we need to specify a time value, and we can also specify modifiers. The two values I'm going to specify here are, where's it gone? Date time. It's not explicitly called out in here, but we can use the now here. So this will always enter the date time when the row was created. And we're also going to specify UTC, coordinated universal time, which just means all of our times will be set to UTC as we're inserting them. Let's go ahead and run this statement and refresh here on the right. And then if you're working in dbeaver, you should be able to right click on your tables and view tables. And if you come over to the diagram, you should see something that looks loosely familiar from here. So what we have is our customers have an ID, which is related to this customer ID, and our products have an ID, which is related to product ID. Hopefully you're following along so far. One more important note for foreign keys in SQLite that tripped me up in an earlier take. SQLite is obviously a very long-standing piece of software, and for backwards compatibility purposes, foreign key constraints are disabled by default and must be enabled separately for each database connection. You can see if foreign keys are turned on by running the following command, pragma foreign keys. And you'll see in here, mine is set to 0. If I set that to on, and then I highlight just pragma foreign keys and run that again, You see foreign keys is now set to 1. And what this is going to do is it's going to make sure that our foreign keys, all of this on delete restrict, on delete cascade, and the fact that the ID must exist for it to exist is going to be honoured. And I'll show you what I mean by that. Let's go ahead and just try and brute force an order in without a customer. Because if we take a quick look at our customers table, you will see we have no customers yet. So let's go ahead and insert. Just bring this up on the side in case anyone needs it. Insert into customers. We have an auto increment the ID. We don't need to insert that. We can just do product ID and we can do customer ID. And the created app has a default value. We can say values 1, 1. So this would be 1 is iPhone. So we are going to place an order for an iPhone, and customer ID 1, which doesn't exist. If we go ahead and run this, what have I done wrong here? Insert into customers. Insert into orders. There we go. Run this. A foreign key constraint failed. And basically, that's because we don't have a customer yet. So let's go ahead and insert into customers, email, values. And for these purposes, to make sure I don't accidentally use a Gmail that someone actually has, I'm just going to use @example.com. And we're going to have to build a few statements out here, but if we select star from customers, we can see ID1 for our customers is set to a@example.com. Now, if we go ahead and try this statement again, we now have a customer with an ID of 1, and we have a product with the ID of 1. So let's go ahead and insert an order into the database and see what it looks like. Order number 1 has a product ID of 1, a customer ID of 1, and it was created on the 9th of May 2026 at 13:16 UTC. I'm obviously in British summertime. My time is actually 17:13. UTC is Coordinated Universal Time. Let's also say, and again, this is a very annoying web store at the moment. Let's say customer number 1 also wanted to order a toaster. So let's go and check what was our toaster. We're going to do it in GBP for now. Our toaster is ID 4. So we are entering the product ID and the customer ID. So ID 4 and insert that in. And let's have a look at our orders table. And we are now entering a second order with these values. I'm going to go ahead and create a new customer, and let's have a look at what happens when we try to delete some things. So let's create z@example.com. And we are going to make Z order the same products. So I'm just going to copy and paste these two statements and put 2 and 2 and run that statement and run that statement. And let's have a look at our orders table, make sure everything is as we expect. Marvelous. So these are essentially identical rows apart from the ID and the created app. However, if you remember up here, we specified that the customer ID was an integer. It references customer ID, and on delete, we were going to cascade that. So let's have a look at what happens if we delete customer number 2, z@example.com. See what happens to our orders table. And what I might do is just open yet another SQL script so we can just come back. I'll close this tab for now. So we can just come back and see how the orders table has changed. So at the moment, the orders table looks like this. If I go ahead and I say delete from customers where ID equals 2, and that is we are deleting z@example.com. Z has these 2 orders. I'm going to run this. Says that it worked. Let's have a look at our orders table. We never ran any command against the orders table, but in the background, what happened was SQLite recognized that we said when we delete this customer, we want to delete their orders too, because we specified on delete cascade, which was very different to the product. And we have some things we can use here as well. So we've got our toaster as product ID number 4. So what we're going to do now is we're going to delete from products where ID equals 4. And this is going to say we're going to delete this toaster from the products table, and are we going to expect it to disappear or not? Because we've got an on delete restrict up here. SQLite constraint trigger, a raise function within the trigger fired, causing the SQL statement to abort. Let's have a look at our orders. They're still there. Let's have a look at our products. They're all still there as well. And what's happened is this on delete restrict, this foreign key constraint has restricted us from deleting that product in that database. And these can be used really powerfully because you can have multiple linked tables, multiple sort of keys deep, if you would like, where you are cascading, but on the last layer you might restrict and it will abort the whole statement. You can have it sort of roll up, roll down, however you'd like to do it. It's really useful if you understand the business logic of your application, which is why a lot of planning goes into building databases and their structure and everything else. It's really good to know exactly how these are going to work. The other important note is that will not have worked if you didn't use that pragma foreign keys. I believe it was, where's it gone? Pragma foreign underscore keys equals on. If it's off, those constraints won't be honored and it would just happily go ahead and delete it. Cool. So we've got our view here of what this orders table looks like. I am going to move this down a little bit so that I don't accidentally run anything. And now we're going to look at some very basic joins. When you're working with tables in SQL, one of the powerful things about relational databases is you are able to join tables together. They don't have to be on specific keys. They don't have to be on anything at all. You can do something like a cross join, which will just join on any condition you specify. However, we're going to use some more explicit joins. I have found yet another Stack Overflow article, which has not only got a very commonly known diagram, commonly seen diagram. People often use Venn diagrams to demonstrate joins. It's also got a comment which demonstrates how all of these different joins would work. And We will get onto more joins later on if you don't want to read about them all now. For today, we're just going to use a basic join, I think. Couple more things to note. You can also do something called aliasing, sort of, give a table another name, and I am going to call this table O for the purposes of this join constraint. So we are going to say select O.id. And what that is saying is we've named this orders table O, and therefore we can say O.id. I believe as well, if I come to my select, can we table or subquery? Yes, so you can, if we followed this through, select your result columns from a table or subquery, and your table or subquery can be your table name. You can specify as if you would like, which some people like to do. So that says orders as O, which means we are calling orders O. You can do something like O.star. We won't be doing that for our query because that won't work, I don't believe. Yeah, but that will return the same value. For the time being, it won't work once we start adding some more tables. But what we can do is we can say we want O.id. We're going to get the product in a different way, but we can say O.customer ID, and we can say O.created at. And I need to put some commas before these. There we go. So if I run this, we should see everything, but without the product ID. Now the join syntax comes, we have to specify a table or subquery, but then we can put our join clauses. So we have to come down to join operator, which for the time being, we are just going to use something called, I believe its full name is inner join. I normally just use the word join. Join, and we are going to join the products table as P. And what we're saying there is we want to join this products table onto this orders table, and taking just English language as it is, that sort of makes sense in my mind anyway. We are joining one table with another table. However, the join constraint is what matters here. So we can say join as P, but we don't know how we're joining. We need to put a constraint on that to know what we are joining these two columns on. So let's go ahead and use the on keyword and then use an expression. And the expression I'm going to use is O.productID equals P.id. And if you remember back from, if we scroll up here, so orders has a product ID. So we've aliased that table to be called O now for this query. We are saying take the O.productID equals the products, which we've aliased as P, the ID. And we are saying we need to join these tables where the order product ID equals the product ID. If we ran this statement, exactly the same thing would come back. However, we can put p.id in here, and let's just double check result column. SQLite actually doesn't mind that. Some database engines will complain if you have two columns with the same name, but we could alias that as and then I believe it is double quotes for SQLite product ID. And run that. Yeah, so you'll see we've renamed this column to product ID. Or now we've joined this table, we've got all these values. So why don't we go ahead and take the name, price, and currency out? And we can do that like so. So we can say p.name, and we could alias that as well to be product name. We could alias this to be, what was it? The price and currency, p.price and p.currency. And we could also alias these to be product price and product currency. No errors. Let's see what this looks like. Not enough space to display it. So we have started to build something out here. We've got the order ID. Again, this ID now isn't making a lot of sense, so we should probably alias that. Run that again. We've got the order ID, order 1. We've got the product ID 1. But we were able to use this join to say we want to fetch back the product name, the product price, and the product currency. And we've labeled those using aliasing as well. Product name, price, and currency. And after that, we were also able to fetch back the customer ID and the created app. So just something for you to try, because you can have as many joins as you can join to your heart's content on the bottom of this. Why don't you have a go, before I go ahead and do it myself, at joining the customer table onto this one as well and pulling back the customer email after the customer ID. Okay, pause the video if you want to have a go at that, but I am going to go ahead and carry on. So we're going to use our keyword join, and we are going to go ahead and fetch customers, and we're going to alias this again as C on o.customer ID, because in this table we called the customer ID equals c.id, because the parent table is the customers table and we want to join back against the ID. It doesn't matter that these are foreign keys at this point. This is just, you are able to join on any columns you would like, as long as they've got matching values or they match the join constraint. But we are now joining on the customers table. So we can go ahead and after our customer ID, we can put a new line, comma, c dot email, and we can run this statement, which is going to pull back our customer email. I think that's probably going to be enough for today, or for this video at least. Feel free to move on to the next video if it's posted already. That is just a very basic introduction to joins. The join that we have used is, like I said, it can be called an inner join. Most people would start with an inner join or a left join, but we are just using inner joins in this case, and this will only, for reference purposes, it will only pull back rows that match in A and B. But because of our foreign key constraints that we set up, we know these columns are primary and foreign keys. We know that those are matching anyway, so we know that they do exist. Fantastic. Okay, I will stop this recording here, and in the next video, we'll have a look at how we can start enhancing some of these to maybe see the total value of orders the customers ordered, or how else we could build upon these queries that we're building. Thank you very much for watching.